All right, so this lesson is about symmetry, and a lot of you understand or already know this idea that it's if I cut something in half, it's going to be the same on both halves, right? So if I cut the letter U in half, for example, so if I draw the letter U, and again, if I were to cut that in half, going down like this, it would be symmetrical, right? Because it's the same on both sides. However, it would not be the same if I cut it in half this way, correct? So a lot of you have understood the idea of, oh, this is symmetrical, and most of us just say, oh, it's when it's up and down. But this year in pre-calculus, we're actually going to learn about symmetry not only going up and down, but also across and diagonally. And again, we'll talk about all that. So, x-axis symmetry is the official name that we're looking for here, okay? So x-axis symmetry means we want the graph to be symmetrical on the x-axis. And another way I want you to think of symmetry is the mirror, okay? So the mirror is on the x-axis, meaning here. There's the x-axis. So if I were to make this graph here on that first example I just drew a line for, the symmetrical part of this half circle would be here, correct? That is x-axis symmetry, because see how it's the same on both sides of the x-axis. So for this example here, the one next to it with the triangle and the little rectangle there, again the x-axis is my mirror, and I'm just going to mirror whatever's on top of the x-axis below it. So this would be the symmetrical picture. Right? Does that make sense? All right, so if you were, again, taking notes at home or going to test yourself, how would you do the next graphs? How would you do the next pieces here? Go ahead and pause the video if you need to test yourself, but here I go. So again, the mirror is the x-axis. So this first part comes down like this. The second part goes up like this. And then a arrow goes like this. See how each piece is symmetrical to the piece below or above the x-axis. All right, then we have this graph here. Again, there's the mirror of the x-axis. So it's going to look like that. And then we have the point 2, 3. Again, if it's x-axis symmetry, I'm going to move down here. Now it's kind of weird because now I'm actually using numbers and data, or before it's pictures, I'm just doing rough sketches. But here, think about it, if it's symmetrical, it's going to have to be the same exact distance away from the x-axis, right? And so this point is, so to get from the x-axis, which is 0, up to here, which is 3, I have to go 3 units, right? So this has to be at -3. So the x value is 2, but the y value is -3, right? Because to get from the x-axis down to that point is -3. So the symmetrical point is 2, -3. So notice that when it's x-axis symmetry, the x value doesn't change. When it's x-axis symmetry, the x value does not change. The x value does not change. Okay. So I bet you can make a prediction. If we've done x-axis symmetry, let's go ahead and talk about the y-axis symmetry. Okay. So again, this time the mirror is the y-axis. Okay, so it's right here. And this part of the graph looks like this. Again, here is the y-axis, the one that goes up and down. So this part of the graph looks like that. Ooh, this one's a little trickier, this third picture here. Again, my mirror is right here. So it's going to look something like this. Right, same on both sides. Okay. All right, for this fourth picture here, again, make sure it's the mirror is the y-axis. All right, now we're back to points. So remember, with x-axis symmetry, the x value does not change. For the y-axis symmetry, think about it. What's not going to change? The y value does not change. Okay, so the y value does not change. Okay, so the y value doesn't change. And so that means I'm going to go, it takes me how many steps to get here? So that's 2 comma 3. So here's 2, here's 3. All right. It's going to take me 2 steps to get here, so I have to go 2 steps over. Okay, so my new point is, again, think about it conceptually. If the y value doesn't change, that means the y value is still 3, but the x value changes to -2. Okay, so, and you'll also notice, I mean, if we go back a slide real quick. So when we did the x-axis symmetry, notice how the numbers don't change, like 2 and 3 are still the same, but the only thing that changes is the y value in the x-axis symmetry changed to negative. Same thing happened here, right? It changed, the x value is what changed to a negative. So interesting. All right. So let's go ahead and go here to -4 comma 3. Again, the y-axis is my mirror. Okay. And again, I'm here at -4. And so to get to the mirror, I had to go 4 units. That means I have to go 4 units this way, meaning I'm at +4, +3. Notice how my y value did not change when I have y-axis symmetry. It was just the x value that switched from positive to negative, okay, or from negative to positive in this case. All right. Now the third kind of symmetry that we just talked about is actually called origin symmetry. Okay, and origin symmetry, okay, is a little bit trickier. In this case, rather than the mirror being the x-axis or the y-axis, it's actually the origin, okay, which is kind of hard to explain, but essentially, here's the origin, again, here at 0, 0. And the way I want you to think about it is, it needs to be reflected over the x-axis and the y-axis at the same time. Okay, so reflected over the x-axis and the y-axis at the same time. Okay, and so the best way to describe it would be to so if I do this, I just reflect it over the y-axis, and if I do it again, I'll use a different color here. So reflect it over the x-axis. Okay, so I had to reflect it twice. Okay, so I reflected over the x-axis and the y-axis. And this would be origin symmetry, okay? So the thing I did in orange there. So if I have to reflect it over both in order to do origin symmetry. So both values change here. So both x and y change. All right, and we're going to fill in the quad 1, quad 2 thing here in a second, but we'll keep going. All right, so if it says origin symmetry. So first again, you can go in any order. So I went over the y-axis, then the x-axis. You can do over the x-axis first. So x-axis, then the y-axis. And again, the orange graph is my actual answer for origin symmetry. Okay. And then for this picture here, again, we'll do it over the y-axis first. So y-axis. And then we'll do it over the x-axis. Whoops. It's kind of hard to think about it for a second. There we go. Something like that. Okay, so you have to do it over both axes. All right, so 5, 3. Okay, so now we're doing it with points. So if I do it with points here, again, what's reflected over the x-axis first? So I have to go. So I went up to 3. That means I have to go down the -3. Okay. So this is at 5, comma -3, and then I have to reflect it over the y-axis, which was at 5. Now it has to go to -5, right? So it would be here. So this is now rotated about the origin. So notice how both the 5, 3 became both negative, and that's that. Okay. And then this one down here, I covered it. Whoops, screenshot error. Let's say that's -4, and let's say that's -3. Okay. So -4, -3. Again, if rather than having to go through both steps of reflecting over the x and the y, again, algebraically, just change the signs of both for origin. So if it's -4, I go to +4 on the x-axis. If it's -3 on the y, I go to +3 on the y. So this would be the point I reflect. Okay? So the easiest way to kind of remember this would be x-axis symmetry. The x value doesn't change. Again, I'm going over the x-axis. For y-axis symmetry, the y value doesn't change. I'm just changing the x value from positive to negative, or negative to positive. For origin symmetry, both values change from positive to negative, or negative to positive, or a combination of both. And it's really like we are reflecting over the x-axis and the y-axis. Okay, so that's kind of the general idea of how symmetry works. Oh wait, let's fill this in here. So quad 1. So in all our examples where we started in quad 1, we actually go to quad 3, so I'll do Roman numerals here, and it's also vice versa. Okay, so if I can go from 1 to 3 or 3 to 1, and then if it's 2, I can go to 4, and again, like we said, we can go vice versa from 2 to 4 or 4 to 2. Okay, so it's always that way. So another way to think about it: odd quadrants go to odd quadrants, even quadrants go to even quadrants. Just an idea. All right, so that's the general gist of symmetry. I'm going to do another video to explain how to actually do this with algebraic expressions as opposed to just shapes or general geometric shapes and with just points.